Here we're asked to find the integral of a complicated function, 2 times x times the square root of 1 plus x squared dx. Well, we know that the fundamental theorem of calculus note told us that the integral of little f of x dx is capital F of x plus c, where capital F is called the antiderivative of little f. In other words, if we took the derivative of capital F, it would give us little f for the answer. So we're going to have to find the antiderivative of little f. Okay, so to answer this question, what we're really looking for is the antiderivative, which we call by the name capital F, of the function little f, which is the integrand of the question, 2x times the square root of 1 plus x squared. The problem is that this integrand, this little f, 2x times the square root of 1 plus x squared, looks like it's so confusing. It could actually be the result of applying the chain rule on some complicated function. So what we're looking for here, let's restate what we're looking for. We seek a composite function, capital F, whose derivative is little f, which is 2x times the square root of 1 plus x squared. Let's find this capital F. Now, you could just take a guess, but you could be doing that all day long. So we're going to use the method of U substitution. It's a cleaner way to find these complicated antiderivatives. Step 1, we choose U. It makes sense to just look at this given question and let U equal the radicand, the function under the square root symbol, 1 plus x squared. Let's work with that and see if that does it for us. Step 2, use a definition of differential, du equals u prime dx. Well, du would then be the derivative of 1 plus x squared parenthesis prime dx, which is du equals 2x dx. Okay, we've got our u, we got our du. Step 3, rewrite the integral of f of x dx that they gave us as the integral of f of u du. You must have du at the end. See, what I want to do is use a slight modification of the note that we had on the top of this question, the Fundamental Theorem Part 2. The integral of f of u du is equal to capital F of u plus c, where capital F is the antiderivative of little f. Okay, let's do it. The original question, integral of 2x times the square root of 1 plus x squared dx. I'm just going to rearrange things. It's the integral of parenthesis 1 plus x squared to the 1/2 power times 2x dx. See what I have at the end? 2x dx. Guess why I put that there? This is now equal to the integral of u to the 1/2 times du. See, that whole 2x dx at the end is du. Great, now let's apply the fundamental theorem. We get u raised to 1 more to the exponent. Add 1 to the exponent, and then we're going to be dividing in the front, multiplying by the reciprocal. And don't forget c, add your c. So we have u to the 3/2 times the reciprocal, 2/3 in the front, plus c. So that's 2/3 times, replace u with 1 plus x squared. Then that's raised to the 3/2 plus c. Now I claim that is my answer, but I have a chance to check to make sure that it really is my answer. It has to be the antiderivative of the given integrand at the top of the page. Let's see if it is. Take the derivative of 2/3 1 plus x squared to 3/2 plus c. That's 2/3 times the power 3/2 times 1 plus x squared to 1 less than 3/2. And, there's a 0 at the end because the derivative is c, but what I forgot to do is hit it with the chain rule. I'm taking the derivative of a composite function, so I have to multiply it by 1 plus x squared prime. That's the chain rule. So that gives me 1 plus x squared to the positive 1/2 times that hit that I gave it, 2 times x. And that is indeed exactly the integrand of the original question. So yes, my answer is good.